Welcome back, everyone, to another deep dive.
From AI-inspired insights from farmers.
If you're enjoying what we're doing here, we'd love to hear from you too.
Absolutely.
Hit that like button, subscribe to the channel, and definitely leave a comment telling us what you want to see more of on this deep dive.
We're always looking for new ideas, and we really value your feedback.
So what farm-related mysteries are you dying to uncover?
Right.
What questions are keeping you up at night? Let us know, and maybe we'll tackle them in a future deep dive. Today,
Welcome to the deep dive. Today we're diving into something really cool, this interception of technology and ocean farming. I mean, think about it. So much potential there for doing things sustainably, right? For finding some innovative business models. I think if you're even remotely considering, getting into farming, or maybe you're just fascinated by these kind of like cutting edge solutions to problems, then this is going to be a really cool deep dive for you.
yeah, absolutely. I mean, I think the goal today is really to kind of extract these like key insights into what the future of ocean farming looks like, especially, with all these advanced technologies that are starting to transform it, right? And what that means for, anybody who's considering, cultivating the sea, farming the ocean.
Exactly. Yeah. And to do this, to really like dive into this topic, we've got a really interesting collection of sources here, some recent research, some updates from the industry, reports that really detail this powerful combination of artificial intelligence and marine technology. So maybe we can kick things off with a look at one of the kind of like fundamental aspects of ocean farming, right? Like kelp and seaweed cultivation.
Yeah, for sure. That's a huge sector, right? Within ocean farming, that whole kelp and seaweed cultivation piece. And, it's interesting because for centuries, actually, these marine resources have been used in so many different ways. You think about it. Culinary applications, animal feed, cosmetics, even fertilizers and medicines, they use kelp and seaweed. But, beyond all that history, I think what's really exciting is how technology is now making it possible for us to get even more potential out of seaweed in a sustainable way.
Yeah. Yeah, and I think, as we're thinking about this, as demand increases, we also have to like look at the environmental implications of all this, right? Like,
Yeah.
I mean, natural populations of kelp and seaweed, they're susceptible to overexploitation. So
Yeah.
it's really important, right, that any new farming initiatives in this area, they have to like really prioritize sustainable practices to safeguard these like delicate marine ecosystems and the biodiversity, of course, too.
Absolutely. Absolutely. And that's where, AI is really making, I think, remarkable progress. Like you look at the iCulture project over in Europe, and that's this collaborative effort, right? With a really clear aim. They want to use seaweed and kelp sustainably, but also like really protect marine biodiversity at the same time.
Yeah, and I think what's so compelling about iCulture is like how AI is being used. It's not just like observing things, right? It's actually investigating, the susceptibility of the existing kelp and seaweed species, and even more than that, they're actually using AI to discover like new species, entirely new species that could have, a lot of commercial value.
That's right. Yeah. And it goes beyond like just identifying species too. Like this project is also developing this AI approach to optimize how we use resources,
Sure.
which is really interesting. So right now, a huge portion, like over 70% of the plant material that gets harvested ends up not being used, like
Yeah.
it's waste.
And this is where it gets really interesting, right? Because this AI, it guides these like specially modified bacteria to consume that waste material, but it doesn't just get, discarded. It actually gets converted into valuable compounds like
Yeah.
antimicrobial molecules, antioxidants. So it's like taking something that was just a byproduct and actually turning it into something valuable.
Yeah, and it's really ingenious, and I think it's interesting where they get the inspiration for these AI algorithms. Like they're actually drawing from strategies that are used in these really complex computer games, like StarCraft or Civilization. Where it's all about managing resources efficiently and strategic planning.
Right. Right. And it really speaks to, I think, the interdisciplinary nature of all this research, doesn't it? I mean, you've got marine biologists working with, geneticists, AI specialists, engineers, even social scientists, people from the industry, all coming together to contribute.
Yeah, and that's so important, right? To have this like really collaborative approach. You need that when you're dealing with these kind of complex like challenges. And another thing that iCulture is doing is they're using AI and machine learning to analyze huge amounts of data. Like we're talking over 80 terabytes of information. And the goal there is to determine like the best times, the best places for sustainable harvesting, right? So balancing the need for resources, but also like critically protecting the ecosystem
Yeah.
and doing all that with like less invasive methods.
Mm-hmm. Yeah. And then, across the Atlantic, you see kind of similar AI-driven advancements in sensor technology, specifically for seaweed measurement. Like
Yeah.
there's this project, Canada's Ocean Supercluster project.
Yeah, and what I think is really interesting about that initiative is this partnership between Coastal Carbon and Holdfast. They're developing these like small, unobtrusive sensors that are actually AI enabled specifically to do remote monitoring of seaweed biomass.
Yeah. And I mean, that sounds like it could be like super transformative for Canadian seaweed aquaculture,
Yeah.
especially for like remote communities, indigenous communities,
Yeah.
who maybe have limited resources for the kind of detailed monitoring that's usually required.
Exactly. Yeah. Having access to these like more affordable, AI-enabled sensors could really empower those communities to
Yeah.
manage their seaweed resources sustainably. And it's cool because it allows them to integrate their traditional ecological knowledge with this cutting edge technology. And then also it's worth noting that this project actually got funding through the Pan-Canadian AI strategy.
Mm.
So it kind of shows you how important this work is on a national level.
Right, right, yeah. So then kind of switching gears a little bit, now that the seaweed is, harvested, there's some really interesting research coming out of Malaysia by Dr. Adibi Noor. He's focusing on AI for quality and safety monitoring.
Yeah, and that's really critical, especially when you think about how ocean farms are like exposed, right? It's the open environment. So there's always a risk of contamination, from debris, heavy metals, even bacteria.
So Dr. Noor and his team are developing this AI software that's designed to spot these impurities. And what's really impressive is that this AI, it actually has the potential to be even more accurate than manual inspection. Like even when the contaminants might be, partially hidden.
Right, and having that enhanced detection capability is so important for making sure that commercially available seaweed has consistent quality, and then also the automation piece of it. AI bringing automation into the process can really improve efficiency,
Yeah.
reduce costs compared to the traditional manual inspection. So it's a win-win for both the producers and the consumers.
Yeah, it's amazing. I mean, to see how AI is being applied throughout that entire life cycle of seaweed farming, from cultivation to quality assurance. But it goes even beyond that. Like, there's this Google AI project in Australia, and they're focused on mapping and restoring kelp forests.
Yeah. And that's addressing this really big ecological concern.
Yeah.
Giant kelp forests they're so important. They provide habitat, they provide food for all sorts of marine life, and they're crucial in capturing and storing carbon. But unfortunately, these ecosystems they're declining because of climate change. In some regions, like Tasmania, they've seen devastating losses, like
Yeah.
huge losses.
Yeah. So to address this, Google is like bringing all their tech power to bear, right?
Hmm.
They're using Google Earth Engine and Vertex AI to analyze like massive amounts of satellite imagery so they can locate these remaining kelp forests, and it's on a huge scale. Like it's like finding a needle in a haystack but underwater. Yeah.
It really is. And they're also using AI in a really interesting way to analyze the genetics of the kelp that has survived, like the heat-resistant kelp. So by figuring out what those genetic traits are that allow some kelp to withstand the warmer water, they can then focus their regrowth and restoration efforts on those more resilient varieties.
And what I really like is that Google is actually making the geospatial map and the AI research tools that they developed, they're making it all openly accessible, which is really huge, right, for global conservation efforts.
Absolutely. And I think thinking about all these advancements in AI-powered kelp farming, there's so much promise there for people who are thinking about maybe getting into this field. The potential for using resources more efficiently, better predictions for yields, better quality control, and even the chance to contribute to these really important ecosystem restoration efforts. It's a pretty compelling area.
Hmm. Yeah, for sure. So then maybe we can shift gears a little bit and look at something that the Seattle Aquarium highlights, which is this idea of the ocean's natural capacity to capture and store carbon.
Right. And their materials really point out how important kelp forests are in that whole process of carbon sequestration. And while the sources that we have don't really get into specifics about like specific carbon sucking technologies beyond this natural mechanism, but I think it is important to really emphasize that healthy kelp forests,
Hmm.
especially ones that are managed with AI, they can really enhance this natural carbon capture,
Yeah.
which really fits in nicely with those broader sustainability goals for new ocean farmers.
Yeah. Yeah. Okay, so building on this whole like ocean monitoring theme, maybe we can jump into the world of cutting edge underwater robotics, and maybe a good example of this is the Seattle Aquarium's ROV called Nerio.
Yeah, and Nerio is really a great example of how we're starting to study and interact with these underwater environments in a whole new way.
Yeah.
Traditional methods like scuba diving, they have limitations, right?
Sure.
In terms of how far you can go, how long you can stay down there,
Mhm.
and satellite imagery, it can miss kelp that hasn't reached the surface, or other important things like characteristics of the seafloor.
Right, right. So these ROVs, like Nerio, they become like super valuable, and it's described as being pretty compact, relatively affordable compared to older models, and it's really maneuverable, and it's got all these like bells and whistles, right? Cameras, lights, sonar, GPS. So it's basically giving researchers like eyes and ears under the waves.
Mhm.
And what's kind of cool is that it's controlled with an Xbox controller, so it's surprisingly user friendly.
Yeah, and that ease of operation is a big part of why it's so effective.
Yeah.
Nerio can capture images of way more species over a larger area than a diver could. And the sonar allows it to stay at like a consistent altitude above the seafloor. So it's really good for what they call benthic surveys, which is surveys of the seafloor.
So what kind of like specific information is Nerio actually gathering?
Well, mostly it's helping researchers figure out like kelp abundance, kelp distribution. So where is the kelp and how much is there? And it also gives them insights into like the types of surfaces that the kelp is growing on, and what kind of animal species are living in those underwater forests, whether they're competing with the kelp, eating it, or just coexisting.
So then this data, it's not just being collected, right? It's being used.
Absolutely, yeah. The images and videos from Nerio are being analyzed by AI algorithms,
Hmm.
and that allows for really fast, efficient identification of species and assessment of how healthy that kelp forest is, way faster than if they were just doing manual analysis.
It's like this really powerful synergy, robotic data acquisition, feeding AI-driven insights, and then that knowledge goes directly into these habitat restoration efforts.
Exactly. Yeah. Understanding like what conditions support healthy kelp growth,
Mm.
that's crucial for any restoration project to be successful. And looking ahead, I think there's huge potential for these kinds of underwater robots to help with, maintaining future ocean farms, monitoring them, even harvesting. It could make things a lot more efficient, a lot less labor intensive.
So putting it all together, the AI-powered kelp farming, the natural carbon sequestration that you get from these healthy kelp forests, the advanced underwater robotics, like what does the future of ocean farming actually look like for someone who's thinking about, getting into this field?
Well, I think what we're seeing is this picture of a really technologically advanced industry that's really focused on sustainability.
Yeah.
And and there's this like convergence of all these really powerful tools, AI, IoT sensors, digital twin modeling, predictive analytics, and it's all coming together to revolutionize the entire seaweed industry supply chain.
Yeah. And the Below Evolution article, it really highlights this convergence. So maybe we can kind of dig into some of these key areas. Like how is AI actually impacting research and development in this sector?
Well, one of the big ways is through predictive analytics. AI-driven predictive analytics can really speed up research by analyzing these huge data sets. Researchers can figure out which strains of seaweed are promising, and they can optimize growth conditions a lot more efficiently. And then there's these digital twin models, which are they're basically virtual representations of the seaweed farm that are informed by real-time data coming from IoT sensors out in the field, and that allows them to kind of run simulations of different farming scenarios in this virtual environment. So they don't have to do as much like real world experimentation, which saves a ton of time and resources.
And what about like scaling up these operations? Because that's always a big challenge, right? For new farms, whether it's,
Yeah.
land based or in the ocean.
Yeah. And that's another area where digital twins are really helpful. They can actually simulate that scaling up process, and they can predict what the environmental impact's going to be of increasing production, like how it's going to affect water quality, nutrient levels, things like that. And by analyzing this data in real time, farmers can adjust their practices to make sure they're optimizing production, but also minimizing their impact on the environment.
Mm. And it seems like this technology is also really helping to streamline the supply chain too.
Yeah, for sure. Like AI and predictive analytics can really optimize supply chain logistics by taking into account things like weather patterns, transportation routes, market demand,
Hmm.
and that helps to keep transportation costs down, reduce delivery times, and optimize inventory management. And digital twins can even simulate different supply chain scenarios to figure out where there might be bottlenecks and how to improve efficiency overall.
It's almost like this AI enhanced approach is leading to these farming operations they're way more responsive and adaptable, to changing
And
conditions.
that's a huge advantage. Having these digital twin models
Mm.
that are constantly analyzing real-time data, it means that seaweed farming operations can be really agile. They can adapt to changes in the market, changes in regulations, changes in the environment. And that means that they can make proactive adjustments to optimize their operations, manage costs, and ultimately, be more profitable.
So for someone who's maybe thinking about starting an ocean farm, these technologies aren't just like futuristic ideas, right? They're actually tangible opportunities for building a business that's efficient, sustainable, and potentially really profitable.
Exactly. Yeah, the future of ocean farming is very much tied to these technological advancements,
Yeah.
and it's giving new farmers some really powerful tools to be successful.
Hmm. Okay, so now for a little bonus insight here. I think it's really interesting to think about how these underwater innovations they could actually have implications for land-based sustainable agriculture too. Like it's fascinating to think about how the precision and the data-driven approaches that we're seeing in ocean farming could potentially reshape how we do sustainable farming on land.
Yeah, it's a really insightful connection. Like take the AI powered sensors that were developed for monitoring seaweed biomass. Could we adapt those to monitor crops on land? Imagine being able to track the health of your crops remotely, or monitor the soil conditions, or even your water usage with that level of accuracy.
Yeah, I mean the potential applications there are huge. And then you think about, those underwater robots that we were talking about.
Right.
Yeah.
Yeah. Using ROVs underwater for surveys, for maintenance. That could definitely inspire, new robots for
Yeah.
land-based farms. Robots that are more autonomous, more efficient, that could,
Hmm.
could help with things like planting, weeding, harvesting,
Hmm.
especially for crops that are really labor intensive or that are grown in challenging environments.
And then the digital twin modeling, that's proving to be so valuable for simulating these complex marine environments.
Yeah. We could absolutely apply that to land-based farms too. Like imagine creating a virtual model of your farm that can predict your yields, that can help you optimize your resources under different climate conditions. Even simulate the impact of different farming techniques before you actually implement them in the real world.
Yeah.
So you can minimize risks and really maximize efficiency.
Hmm. Yeah. It really shows you how innovation in one area of agriculture it can have these like surprising ripple effects,
Right.
and that drive towards sustainability and efficiency. It's a common thread, right? Whether you're farming on land or in the sea.
Exactly. Yeah. The advancements that we're seeing in ocean farming, they're not just, isolated to the ocean. They offer valuable lessons and technological jumps that can really contribute to a more sustainable and efficient future for agriculture in general,
Mm.
which I think is really relevant for anyone who's considering, a career in farming, or even just for anyone who's interested in the future of how we feed ourselves.
Okay. So to kind of like wrap up our deep dive here, it's really clear that artificial intelligence, cutting edge robotics, and this whole data driven approach, they're not just theoretical concepts in ocean farming anymore. I mean, they're really transforming the industry, making it more sustainable, more efficient, and opening up all these really cool opportunities for new farmers.
Yeah. And as we've kind of explored today, the impact of these innovations, it goes beyond just the ocean. They're providing us with valuable insights and technologies that could very well change how we do sustainable agriculture on land too.
Hmm. So I guess the final thought, the thing to leave you with is to think about how these advancements they might actually influence your own, potential farming ventures, whether that's in the ocean or on land, or even just how you think about the future of food. It's a lot to consider, right? And we encourage you to explore these concepts and the research that we talked about today. So thanks for joining us for this deep dive.
Yeah, thanks for having me. It was fun. Hitting that like button and smash that subscribe.